that changed it from its parent function. So we have x equals x minus 1 squared minus 7. So Aaron, what type of function is this? Do you remember which function family this one's in?
No.
So we had 4 options: absolute value, linear, quadratic, and square root. Which one of those 4 is it? So Aaron, is it absolute value?
Huh?
Is it absolute value?
I don't think so.
No, because absolute value is the one with the lines, right?
Yeah.
Is it linear? Is it a line like y equals mx plus b?
No.
No, it's got this square up there. So there's no x, it's just x squared. Does it have a square root over it?
No.
So it has to be a quadratic. Do you remember what the original quadratic formula, or not quadratic formula, but like a quadratic function with like no numbers in it? Y equals what?
I got it in my notes somewhere.
Yeah.
Y equals x to the second power.
Thank you. And thank you for utilizing your notes. I appreciate that. So this is the parent function. So the things that changed, let me get a highlighter. Things that changed in the function that's on the warm-up were this -1 and -7. So we've got to figure out what those 2 things do. That was the goal of this warm-up. So what does the -1 do? Aaron.
It just.
Does it move it left, right, up, or down?
Left.
So when it's inside of the function like this, it's just the opposite of what it is. So it's going to be right. And by how much does it move?
1.
Yeah, good. Okay, and then what does the 7 do?
Moves down 7.
Yeah, very good. Down 7 units. All right, thank you, Aaron. I appreciate it. Tanaya, how do I do number 2? So first, I guess I'll write it down. G of x equals 1/2 square root of x plus 4. So what's the parent function?
Square root, right?
Oh, can you say it again? You're kind of quiet.
Square root.
Yeah, very good. And how do I write that?
Y equals the square root of x, right?
Perfect, yes. Y equals the square root of x. And then, so the things that changed the parent function in this G are the +4 and the 1/2. Okay, so we'll start with the +4. What does the +4 do?
Doesn't it change so it like it moves left?
Yeah, this is gonna move to the left 4 units. Okay, because it does the opposite of this sign. And then what does the 1/2 do?
Doesn't it compress?
Say it one more time. I think you're right.
Compress?
Yeah, it's it could be a vertical compression, or we call it, I think in this class we use horizontal stretch. Okay, so it makes it look fatter, basically. Okay, you could think of it as a vertical compression, like pushing it down, or you could think of it as a horizontal stretch, like stretching it out sideways. Okay, and it's going to be by a factor
of 1/2.
So when we're thinking of it as a stretch, it's going to be the like denominator. If we think of it as like a compression, then it would be by 1/2. We're like squishing it by 1/2. But when we're thinking of it as a stretch, then we're pulling it out by a factor of 2. That one's kind of tricky though. I always get it mixed up. I have to relook it up every year. And then Francesca, will you do number 3 with me?
Okay.
All right. So what's the parent function for this one?
Y equals X
Almost.
with the lines on it.
Yeah, the absolute value bars. Good. Okay. And then the things that changed in this one are the negative sign, the 4, and the +1. So let's start easy. What does the +1 do?
Goes
when he was a baby. So there's Moana, and she looks so.
goes left. No,
So it's outside of the absolute value bars, so it's gonna go
right. I mean
up.
up.
When it's outside of the function, it goes up or down. When it's inside of the function, it goes left or right. So this one's gonna go up 1 unit. What does the negative sign do?
Go right.
This one flips
Left.
or reflects over the x-axis. And then the 4, what does the 4 do? It's kind of like the 1/2 over here, but this one's a whole number.
So it I have the word, but I don't know how to say it.
So instead of a horizontal stretch, it's going to be a
Vertical.
yeah, good.
Jesus.
Vertical stretch by a factor of 4. Okay, sorry, I got sloppy there. The end notebook was in a weird position. All right, very good, guys. What questions do you have?
How we put the y equals with the absolute values? How we do that in Gizmos?
Oh, that's a really good question. I can show you real quick. I'm gonna move this and downsize this for a minute. Get rid of our warm up. So let me add another tab.
Can you just let it go?
Where's microphone is on? Is that Francesca's? Whoever it is, if you wouldn't mind turning it off, that would be great. So you go to Desmos.com, wait for it to load. And then, so you do y equals, and then, let me see if this works. So you can type in ABS and it'll do it, or you can click this little keyboard at the bottom. And then if you go to functions and then go to miscellaneous at the end, nope, hold on. Where, oh, I'm dumb. It's right here. You just click this guy, type in your X, and it'll fill in the rest for you. Does that help?
Yes.
Okay, so again, you just like start typing, click on the keyboard at the bottom, and it's right here, right above the little ABC thing. That's it. Great question. Okay, so for today, we were going to go through the rest of our Desmos transformations investigation. So I guess I'll leave Desmos up and put up my document camera. And yes, so we'll do the second page of this. And so hopefully you guys have already done this. So we should, if that's the case, then we should be able to like fly through. Oh, and I got new pins today, so I can use colors. It'll be so great. Okay, so for the very first part, it says graph the function y equals x squared. So we put a point at 0, 0, point at 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, and negative 3, 9. So we plot our graph out for y equals x squared. Okay. Oops. And then it says using a different color, graph y equals negative x squared. So let me get a color.
Didn't we do this in last class?
So last class
Different
we should
sheet.
have finished the front. This is the paper that I have for your class. So we went all the way through the front. Yeah.
Oh, okay.
And so now, and we did, these were like translations going left, right, up, and down. So now on the back, we're investigating reflections and like stretching.
Okay.
Okay. Where I literally had a whole thing of brand new pens that I was so excited to use. And I don't even see them anywhere in this room. Of course that would happen. I was so excited about them. I don't know. Oh well. Okay. So maybe I put them. Nope. All right. So we'll just do this. All right. We have y equals negative x squared. So if you have no clue how to graph that at all, then you can just go to Desmos. And you can type in y equals negative x squared. And you see that it's the same thing as the original. So I'll type in the original so you can see it. Except it's flipped over the x-axis. So we would take all these points that we just plotted and just flip them over. Okay, and we would get to draw in this guy. Okay, so does this open up or down?
No.
Down.
Yeah, very good, down. All right, and then it says in a different color, graph y equals negative 3x. Okay, and for this one, it's going to want to know if it opens up or down, but we should try to see what that 3 does as well. So negative 3x squared. Okay, so how does the green graph on Desmos compare to the red and the blue?
It got smaller.
Yeah, I got like skinnier. Okay, so what it's doing is it's taking each of the y values from our original function and it's multiplying them by 3. So normally when I would like square 1, I got 1, but now I'm multiplying that by 3. And so it's going to move up to the points negative 1, comma 3, negative 3, and positive 1, comma negative 3. So it's like stretching everything out, making it skinnier. Okay. But it still opens in which direction?
Down.
Yeah, very good. Okay, so it asks you to do this again, but with positive 2 and negative 2 out front. So what direction do you think the positive 2 is going to open?
Up.
Yep.
Up.
The negative 2?
Down.
Down.
Down. Okay, and let's go ahead and compare. I guess I'll use orange. I want to see what this looks like. Actually, I'm going to do the negative 2x squared because I want to compare it to the negative 3 and see what happens. So what